to my channel. Today I'm going to be covering beginner CNC milling feeds and speeds. Now when I first started out a couple of years ago, I found it very hard to understand the advice I was being given on the forums. I kept on asking, look, I've got this end mill, this is the material I want to cut, what are the feeds and speeds I need? And yes, it's quite vague, and the answers you get are quite vague. But what you're really looking to do is, as the intro has just shown, you don't want that inevitable crash. Now, when you first start, you don't have any idea of feeds or speeds for your end mills at all. And they're going to break. And they're going to be flying around your workshop like you don't know what. So today what I'm going to try and do is show you a neat little trick which will help you get round that, so as it'll get you up and running with the end mills that you buy. The big problem that everybody has is these end mills tend to come from dubious sources such as eBay or even from your local tool supplier, who may not necessarily give you the data that you're looking for to help you use that end mill. So we'll start having a look at what you need to know to get you started. Okay, so let's get started. I've selected my tool from a very dubious source on the internet. As you can see from the drop down menu on the page there, I've selected a 6mm cutter and it has 2 flutes. That's about all the information you're going to get from this source on the internet. Now when you start asking on the forums for feeds and speeds, this isn't enough information, guys. And you're going to find out why the formulas confuse you so much and why you don't get much help on the internet. There's a lot of other variables that make your end mills not work. Your machine rigidity, you know, whether it's blunt for starters. You can have any amount of issues if you use coolant, if you're not using coolant. But what we're aiming to do with this YouTube video is basically just to give you the basics to help you put that first tool into your machine without killing yourself. This is all we're going for. So we're armed with some information off eBay. Now with regards to end mills or cutters, we'll try and use the correct terminology. When you start using automatic tool changers, you'll realise that a tool actually means the holder and the cutter. It's the full package. It's not just the little end mill in the end. When you start listing all your tools in CAM, and it's a list of all of the end mills you have in your collection, you very soon realise that you've made a huge mistake. Yes, I had about 10 tool holders eventually and went, yeah, the cutters are not tools, the cutters are cutters. Everybody calls them tools. You've got to realise that that's what they're talking about. So anyways, we want to move on with this tool, and we want to make our part. Now the next thing to understand is the formulas. Now this is the typical formulas you will find on the forums and what everybody will give you and point out to you and what you were taught at college, and great. So what we have off our dubious source on the internet is a cutter which has a certain diameter and number of flutes, and there is not an opportunity in any of those equations where you can actually put the values in that you have got from your limited information on the internet, which are going to help you use that tool. And this is why I'm doing this video, is because when I first started, I struggled like hell to get people to explain to me how to use the formulas, and I could never quite get my head around it. So this is a basic concept of where you are going to get that information from and how it's going to help you, and I can guarantee that you will end up cutting material with the first end mill you put in your mill, and you'll know a feed and speed recipe that's going to work for your part. So what we've got on the first formula is cutting speed. So this is your SFM, or removal rate, VC. What we're going to do from here is have a look at a chart of material removal rates. So what we have here is SFM, which is the imperial surface feet per minute, or as we use over here in England, the meters per minute for your removal rate. Now, the material that I'm going to make my hypothetical part out of is mild steel, and the material that I know happens to have a removal rate of 35 meters per minute. When we start talking about removal rates, what we're really talking about is this. It's a chocolate bar. As you can see, the honeycomb in the centre of our part here, the way that we engage our tool into that part, we can either smash it into chunks, we can cut little bits off it, or we can absolutely go mental right through the middle of it. This is where your feeds and speeds become important. It's the size of this structure that the material's made of, and that dictates your removal rate. This is actually the mild steel underneath an electron microscope. So you get the idea that it's a molecular structure, that what you're trying to do is engage a tool into to remove pieces of that. And like I say, if you throw your tool hard on in it, as if you're driving a car into a brick wall, you're going to be wearing your tools. So now that we have an idea of what we're trying to do and what the material actually looks like and how we're going to engage that material, we now need to go back to our formulas. So looking at our formula, we can now move on to the first equation, which is to work out our speed. So we're looking for feeds and speeds, so we need to know our speed. So we've got our information here for our 6mm cutter. We know it's a 2 flute, not relevant for this equation, but we have the removal rate of 35 meters a minute. Now we need to convert this equation of the 35 meters a minute so as it's into millimeters. So what we do is multiply that out by 1,000, and you've got the pi times the diameter of your end mill or cutter, which in this case is 6mm, and that gives us a speed of 1857 RPM. Okay, so now we've got our spindle speed, we now need our feed rate. So we go back to our formula again, and we'll look at the feed rate, and we've got the spindle speed. Yep, we can enter that into the formula, and then we have the feed per tooth or chip load, FZ. And we don't have that, we can't enter that into that formula, so we need the feed per tooth. So we have a look down onto the next formula, and we have the feed rate divided by the spindle speed times the number of flutes. We don't have the feed rate, so how do we get the feed rate? This is where the formulas confuse people, because you don't have any information. You have no chip load, so you cannot calculate the feed rate. We bought the end mill from a dubious source, or potentially we could have bought that end mill from a local tool supplier who won't necessarily give you the data. So how do you get the data? Well, quite simply, you go onto a manufacturer's website and you have a look at the data table, and that's how we're going to do it. So first of all, like I was saying, we will step through the formulas. Yep, we can't move there. we don't know our feed per tooth, so we can't calculate our feed rate. So we have a look to see how we calculate our feed per tooth. And yeah, we don't know the feed rate, so we can't reverse the formula back out again to get what we want. We are now officially stuck. So we go onto the website and we say, okay, I have an end mill, and within reason you're going to know what your end mill is made out of, or if it's got a particular coating on it. If it is a dullish silver colour, the chances are it's a high-speed steel tool. If it's slightly blackened in colour, it's going to be a carbide tool. If it's got any particular coatings on, it's either going to be blue, gold, red, yellow. So you're going to know if it's coated. So to try and find a formula that's going to work for a typical end mill for, say, high-speed steel, because this is hypothetically the equation we're going to be working with, if you go on to Marry Tool, or I particularly use my supplier's website, Cutwell in the United Kingdom, they give you data for the end mills. If you don't actually have the data for your particular end mill, you can bet your bottom dollar you won't be far off if you pick something that's in the same ballpark. So we've gone onto Cutwell's website, in my case, and we've pulled up data for end mills, which are 2-flute high-speed steel. So on this page it's given us quite a bit of information. You've got a tab along the top of the data table which is telling you blue or green. So your material is either carbon steel or it's aluminium. In the top right corner you've also got 6 boxes. What they're telling you is that this particular range of end mills, not yours, but this particular range of end mills, is suitable for milling steel or aluminium, not stainless steel, not cast, or titanium, or any other Inconel, anything else that's precious or bizarre. So what we have on, like I say, these 6 boxes along the top, there is an ISO code for those, so you can see what the materials are. Now if you operate a lathe and you happen to have a look for your tool inserts, you will notice that along the top of the page will be the same 6 colours as to whether that insert is suitable for your particular metal or not. Very useful to know what they are. When you see them, you'll recognise them now and you'll go, oh yeah, bang, that's what they're all about. So like we say, we've got our steels in there, we've got stainless steel in there, you've got your cast iron in there, aluminium, other special metals such as your titanium, and obviously hardened steels and cast irons. So there is quite a lot of information on this page here. As we look under the carbon steels, you'll notice that there is 3 grades of hardness along there. So your SFM that we mentioned before, or your removal rates, they're heading from left to right with your softer metals to your harder metals, and obviously the last column is your aluminium. So looking at this chart, if we decide to have a look at all the other information, we can see that if we look down the chart, we've got the 6 mil. So looking along the 6 mil column, we've got the RPM of 1800. The calculation came out slightly higher than that, but yeah, it was within the ballpark. That's exactly what we were looking for. We've got the VC there, the meters per minute removal rate, which is 35 meters a minute, which is exactly what we knew we were looking for off the SFN chart. And now it's given us a tooth load of, I'm squinting to see this because it's very small, 0.025 FZ. That's the figure that we've been looking for. That's the figure that we ain't going to be moving anywhere in our equations if we don't have it. And as if by magic, they've already told you what the feed rate's going to be. The feed rate in this case is 90 millimeters a minute. And when we further look into the equations, you'll find out that this is absolutely bang on. So now that we've acquired our FZ, or tooth load, feed per tooth, we can now start to plumb some values into our equation here and find out what our feed rate is. So from before, we know that we had just over 1800 RPM as our spindle speed. From the data table in the manufacturer's book for our high-speed steel tool, we've found out that the feed per tooth, FZ, is 0.025, and we know that our tool's 2 flute. So that's given us now 92.85 millimeters a minute as our feed rate. And if we go back to the data table and look at the 6mm tool and go and have a look at the feed rate for our soft mild steel material, we will find it says 90 millimeters a minute. So that's how we've managed to circumvent the confusion of the formula by actually having the information there in the first place. Now, whilst we're also looking at this page with the table on, we get into the subject of depth of cut and width of cut. Also very important information which stops you trying to use the tool 100% deep or 100% width and basically ramming into your part. The little tiny diagram right down at the bottom says that this tool is suitable for pocketing, and you can use the full width of the tool, which is rather handy because it would be useless otherwise. And what they're advising is to use no more than 50% of the diameter for its depth. So it's basically telling you that don't go more than 3mm deep with that cutter with that feed rate, and it should pretty much work. I'm not going to cover wok and dock on here, but what you've kind of got is a radial and axial depth of cut. Wok and dock to some people, or the R dock and W dock, yeah, whatever. Rule of thumb is about 25% max. So if you're profiling with this end mill, you don't want your step into the part to be greater than 25%. You certainly don't want to go over 50%, because if you go more than 50% of the diameter of your cutter, you will end up where the actual blade of the cutter, the tooth itself, you're beyond its capable width, because obviously the blades come to the centre and the end, so you'll be trying to use half of the backside of the other cutter, which obviously makes sense. So as you're looking at your end mill and you go, okay, yeah, the blade only goes to the middle, so this 50% on here for the depth of cut and width of cut makes a lot of sense when you start looking at wok and dock. But like I say, we'll cover that in another video much later. But pretty much, guys, that's your basics for feeds and speeds. So if you have got high-speed steel end mills and you go and have a look at a data table for any tool maker, trust me, any tool maker, you will find that it will pretty much be similar, because it's all to do with that magic figure of the removal rate, the rate at which you can smash the crunchy bar to bits, and they're going to tell you what their tool is capable of. Now when you get into the coated tools or the carbide tooling, you can run them a bit harder, but when you know what your tool's made of, you can then go and have a look at carbide table or a coated tool table, and then the same information is going to be out there for you. Hopefully that's going to save you from a lot of pain and get you up and running. It'd be really nice that you put some comments in and said, yep, I'd picked a tool, knew how many flutes I had, put it into my machine, had a look at the data table, picked a basic feed and speed, and wow, it's making chips. That will be music to my ears. Chances are you're probably going to say the opposite, and I'm going to get a lot of criticism and they're going, "Hey, broke on me." But you're going to break a lot of tools before you actually get anywhere, guys. Hopefully we're going to stop the disasters where somebody gets an end mill buried in the forehead, or it scares the living daylights out of them to actually switch their machine on in the first place. But hopefully this has been enough information to get you started. Okay, signing off. Ciao.